Okay, so 12x squared minus x cubed. How do we go? Okay. All right, so determine where the function is concave up, concave down. So in order to answer question A, what is it we actually are finding? Nope. Stationary points. So where, it says, notice it says where. So where the function is concave up, concave down, so we're looking for stationary points. All right, how do we find stationary points, ladies and gentlemen? Let the first derivative equals 0. Yep. Okay, so if that's the case, what is the first derivative of 12x squared minus x cubed? 24x minus 3x squared. Okay so far? Yep. There we go, half a mark. Woo! All right, that's poor. Not at this level. Okay, so we're in unit 4, ladies and gentlemen. That one should be done in your sleep. Okay, so I'm going to let f dash x equals 0. So that 0 equals 24x minus 3x squared. How do I solve that, ladies and gentlemen? Not yet. Will be the next step. What do I have to do first? Factorise in order to use the null factor law. Okay, so common factor of 3x, leaving me with 8 minus x. I think, yep. Okay, so now we factorise. Now we can use the null factor law. Can't use the null factor law without factors, one of those idiosyncrasies of the word factor, needs to be there somewhere. Okay, so either 3x equals 0, so x equals 0, or 8 minus x equals 0, so x equals 8. That's right, now we need to determine where it's concave up and concave down. So how do we do that? Yeah, we can use the first derivative test or we can use the second derivative test. Okay, so because it's a simple polynomial, it's in this case we've already differentiated, so it's a quadratic. If we take the second derivative, it's going to become a linear function. Really easy to work with. Okay, so in this particular context, it's actually very simple just to take, and I'll redraw that because that's just disgraceful. Right, it's easier to do it the second derivative test. Well, as long as it works. We'll find out. It should do. So derivative is going to be 24 minus 6x. Okay? So now once I've found the second derivative, what do I do? Can't hear you?
Insert functions to either side of the
Nope. Nope. That's to find points of inflection. What do I do to find out concavity? Can't hear. I'm deaf, remember? Old and deaf. Work with me. What am I going to do here? Any thoughts? Any guesses? Well, we already know where. X equals 0 and x equals 8. My point is, why are we taking the second derivative?
Sort of concavity.
To find what kind of cavity. So what do I have to do from this point? That's right. I substitute those 2 points into that equation. Okay, so let's do an x equals 0 first, because that's the first point that I've got. So the double derivative of x, double derivative at 0 is going to be 24, because minus 0. Cool? Now, what can you tell me about the number 24 that we care about?
It's positive.
It's positive. So what does that mean? It's concave up. Okay? We also know that concave up means it's a minimum, so keep those contexts in mind. So we substitute the value in, got that. So what about at x equals 8? Derivative is 24 minus 48, sorry, so it's going to be minus 24. Okay, which is quite obviously less than 0, which means we are concave down. Okay? So the function is concave up at x equals 0 and concave down at x equals 8. Is that okay? That's all you have to do. Now, if you'd use the first derivative test to solve that problem, in this particular question, you'd be okay. because it didn't tell you to use the second derivative test. In your exam, hint, 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 for IA4, IA3, right, your Unit 4 exam, there is a question that says, use the second derivative test to find these points, stationary points and points of inflection of this function. It specifically says to use the second derivative test because that's what we're assessing, right? So therefore, if you do the first derivative test, you will not get all your marks because you haven't answered the question, okay? So just be aware that, and I'm being very upfront, there is a question that will ask you to use the second derivative test. I can't be any more explicit than that, without telling what the function is, and I'm obviously not going to do that because that's, not good. All right. Could you have a go, could you tell me what to do for B? Coordinates of the point of inflection. Go. Nope. Oh, what x value? What x value are substituting? No. Why not? Why not those points? What are those points? They're stationary points. Are they points of inflection? No. They are minimums and maximums in this case. Sorry, Doc, can't hear you.
Isn't that something like the halfway?
It typically is, but how do we prove it's that point? Nope.
When the second derivative equals 0.
When the second derivative equals 0. This is what we learnt yesterday, hence the reason we're going back over this question. All right? So, points of inflection occur, there's two conditions, right? The first condition, which is the one we have to start with, quite obviously, is the second derivative equals 0. So we find stationary points when the first derivative equals 0, we find points of inflection when the second derivative equals 0. Okay, so d squared y dx squared, my apologies, because we've got the function notation for this question. So f double dash x equals 0 is is our rule, if you like, right? What process am I using? I'm following that particular theorem or rule. Okay, this is not a difficult question because it's only a linear function. So we're going to have 0 equals 24 minus 6x. And shockingly, I know this is going to come as a complete surprise, x is 4, halfway between 0 and 8. Right? Yeah, absolutely you're right, but we have to show why. Yeah, so the mathematical justification part of it, right? And so now we know that x equals 4. It does say the coordinates, so how do I find the coordinates now? Sub in, yep. So f of 4 is going to equal, what's the function again? 12x cubed, 12x squared minus x cubed. So 12x squared minus x cubed. Okay, so that's, I'm just going to redo that just so 4. It's going to be 12 lots of 4 squared minus 4 cubed. So 4 squared 16, 12, 6, oh goodness me, 12 16s, 144 plus 208? No. Yeah, is it 208?
No.
What is it? No, it's just the 12 times 4 squared.
Yeah, 12 times.
Because 4 squared 16, so 12 12s are 144, and 4 12s, 4 12s are 48, sorry. So 196.
Yes.
Apologies. Sorry about that. And 4 cubed 64. So that's going to be 132. So the point, coordinates of the point of inflection equals 132. Did I get that right, by the way? Is it 132? Can someone just confirm that with their calculator, because too lazy to get mine out? It's actually right there, but
Oh, wait, no.
it's wrong?
I confirm.
Oh.
This time, 16 times 12 is 192,
192.
not 196.
Oh, so close. So it's 128 then.
Yes.
Thank you for correcting. What happens when you use your brain? Make mistakes. We're okay with that? Yep, so that's a bit of a summary of what we did yesterday, a little bit, in one question that you did last night. He says, knocking on. How did we go? Liv, when you look back on how you thought you went?
Huh?
How do you
I
think?
wasn't far off, I just messed up, I used the second derivative It's not
Okay.
calculated.
You calculate as what?
It's not a linear test.
Take the batteries out. Anyone else got any questions, or how'd you go last night when you actually attempted that question? Did we attempt that? Yep. Please.
So if it just says that the water makes it the point of inflection, you don't need to find like the direction.
No. No. Well, we typically should. So you're 100% right. We probably should. So we need to check. Yeah. Thank you for that reminder. Thank you for that reminder. Check. It is a point of inflection. I mean, it's going to be.
Yeah.
But. So how do we check again? Yeah, second derivative test. All right, so we're going to have x and f double dashed x. Okay, so we know that point's 4, so we just pick points 3 and 5. Okay, they're going into the second derivative, so that's a linear function, which makes life very simple. So 24 minus 18 is 6, which is positive, and then 24 minus 30 is negative 2, which is negative. So it changes direction, which is what we wanted to do, okay? If I just scroll back up, right? All right, so the derivative, so the definition for a point of inflection as a reminder, okay, it's where the second derivative equals 0 and the sign changes either side to show change in concavity. What? Good stuff. No, that's good. No, well done. Well done. So, yeah, so you're right. So, thank you for the reminder. Okay, so, yep, we check the value, we find the value, and we just double check by using the second derivative test that she is, that we've got a change in sign. It doesn't matter which direction. All right, so in this case, it goes positive to negative. If it went negative to positive, it's still a point of inflection. That's fine. Okay, so that's how we get that. Okay, so I wasn't going to move forward today. We are going to look at, so next week when we start, we'll start curve sketching from scratch. We don't want to do it today. Okay, so what I thought today would be a good opportunity is to practice some of your questions of this sort of stuff. So this is practicing second derivative and this is practicing concavity problems. Okay, so this is from your Jacaranda, so you should have that online. All right, 8.3. And some questions. So there are some tech-free and some tech-active. Could I encourage you to have a go at a couple from each? All right? And we will, I'm happy to come and help you with problems as you got them.